In this module, we're going to look at route indications that accompany signal aspects and also something known as approach control. We'll start by talking about how routes are indicated on mechanical semaphore signals, then talk about some of the different types of route indicators that accompany colour light signals, something known as splitting distance signals, and then finally approach control. In mechanical signalling, a separate semaphore arm is provided for each route from the signal, and typically in relation to the relative direction and speed of the route. So a high up arm implies a higher speed, a lower down arm implies a lower speed. An arm more to the right indicates a route diverging to the right, and an arm to the left indicates a route diverging to the left. And only one of these arms is inclined, authorising a train to enter a route at once, hence the driver knows not only that the train's authorised to enter a route, but also which route is set for it. In colour light signalling, the same aspect is used for all routes from a signal, so in order to know the route that is set, the drivers need to be provided with some form of route indicators that are illuminated or extinguished to indicate the route and hence enable drivers to control speed appropriately. One of these is known as a position light junction indicator, PLJI, which consists of 5 white lights in a straight line indicating the relative direction of main or Warner routes from the signals. And PLJIs are only typically only illuminated for diverging routes that must be entered at reduced speed and extinguished for straight ahead routes. However, occasionally they are provided for all routes when there is no clear straight ahead route. PLJIs have the advantage of being readable from much greater distances than other types of route indicators. However, there's some for the fact that they are rather limited in the number of indications that they can give on any one signal. So only 6 possible indications, labelled position 1 through to position 6, of which only 3 can be used together owing to the ambiguity of having indications that are effectively a straight line through from one another. Alphanumeric route indicators are another type of route indication that display the route by means of letters and or numbers. Typically 1 or 2 letters are illuminated for each route from a signal, and although they're not readable from the same distance as PLJIs, they do have the advantage that they can provide a much greater number of indications and hence are suitable for signals that have a large number of routes. There are 2 variants, standard or stencil alphanumeric route indicators can be used to indicate any route type. There's a smaller variant known as a miniature alphanumeric route indicator that can be used to indicate calling on and shunt routes. Where the misrouting route risk is particularly high, there may be a preliminary route indicator on the approach to the signal, which gives drivers warning of the route set from the signal by means of a position light indication, an arrow similar to PLJIs with the positions 1 through to 6, plus in addition position 0 for the straight ahead route. And the purpose of this early indication is to enable drivers to stop before the signal from which the route is set if that route happens to be incorrect. Splitting distance also give drivers an early indication of the route set with a view to enabling them to control speed appropriately. Effectively separate aspects are provided for each of the 2 routes from a subsequent signal. So it's sort of like imagine the subsequent signal had separate arms or indications for each route, and this is mimicked in the splitting distance. With one the distance signal is showing a yellow, implying that the route associated with that distance is not set from the subsequent signal, or a green aspect indicating that it is. And this allows drivers to control speed appropriately before getting to the signal from which the route is set. Now, these are only provided in exceptional circumstances. Elsewhere, where routes require reduced speed, it's much more common to subject the signal to approach control, either main aspect approach release from red, MAR, or main aspect approach release from yellow with flashing aspects, MAY-FA. In MAR, a signal displays a red aspect until an approaching train is sufficiently close for the driver to see the route indication. So the driver sees a yellow aspect in the previous signal, causes a train to start braking for the signal from the route which the route is set, and then only when the train is sufficiently close to that signal to see both the aspect in that signal and the route indication, hence gets all the information about the path that should be taken, then can the signal clear and the driver proceed into the route, controlling the speed appropriately. And this mitigates the risk of trains travelling too fast, as the driver is never authorised to enter it without being able to see the route indication. MAR is also used for slow trains down before entering warner routes to mitigate the risk associated with the restricted overlap. Approach release from red, or albeit not main aspect approach release from red, is also used to slow trains down before displaying a proceed aspect for calling on, shunt or poser route, which again trains need to enter at very low speed over to the potential occupancy of the route by another vehicle. Key disadvantage of MAR when used for route indications is it can be unnecessarily restrictive, as trains may be forced to slow down a long way before the junction with a reduced speed, or potentially slow down too much. Hence, there is another form of approach control known as MAYFA, main aspect yellow, main aspect approach release from yellow with flashing aspects, in which case a signal displays a yellow aspect until an approaching train is sufficiently close for the driver to see the route indication for the diverging route, in which case it can clear to a double yellow or a green aspect. So that in itself doesn't actually provide enough information to control the speed appropriately. So it's supplemented by flashing aspects, which we saw in the last module. When a diverging route is set that requires a reduced speed, the previous signal shows a flashing yellow aspect, so the drivers know to start slowing their speed down to the speed appropriate for the diverging route. And sometimes this flashing yellow may even be preceded by a flashing double yellow aspect to give the full braking distance necessary. However, there is a restriction on when MAYFA is used. This can only be used if an approaching driver would see the first flashing aspect at the time when the junction signal could actually step up to an aspect less than restrictive than yellow. Otherwise, MAR is used. And this is to avoid a situation where a driver sees flashing aspects and preempts the next signal stepping up from yellow to a less restrictive aspect, and in fact it doesn't. So to avoid a risk associated with that, actually we make that always the case. So the signal will always step up to yellow, from yellow to a green or a double yellow. So in summer, we started looking at how route indications are provided in mechanical semaphore signallings by means of separate semaphore arms. Then in coloured light signalling, how aspects are supplemented by route indications that are either illuminated or extinguished to indicate the route set from the signal. We looked at position light junction indicators, PLGIs, consisting of 5 white lights in a straight line to indicate the relative direction of main and warner routes, and alphanumeric route indicators indicating route set by means of letters and numbers. And where route routing is high, the role of preliminary route indicators on the approach to the signals from which routes are set to provide an early warning of the route set and allow drivers to stop if needed. We also talked about splitting distance signals that can give early warning of a route set from a subsequent signal, and hence enable drivers to control speed appropriately. And approach release from red, also performing the function of allowing drivers to control speed appropriately for diverging routes, as well as for entering warner routes and to mitigate the risks of this shorter overlap. We saw how approach release from red is also used to slow down trains before entering calling on, shunt or poser routes, and main aspect approach release from yellow with flashing aspects, MAYFA, as an alternative to MAR for controlling the speed over junctions that's less restrictive, as trains don't necessarily have to be slowed down so early or quite so much.